What's up, what's up, what's up? It's your boy, the network, bruh. I still don't have my phone. I've been keeping this room away. I've been keeping the phone out of this garage so I don't get no distractions. Anyway, today's topic is subsection 5.4a, IPv4 access control lists, standard, extended, and time-based. Today we're going to be covering extended ACLs. This is a topic in the CCNP route exam code 300-101 version 2.0. Again, this will be known as a CCNP enterprise exam, but let's go ahead and take a look at the exam blueprint, see where we came from, where we're headed, hashtag labeveryday. I've been saying that a million times, huh? I might have to cut that out. All right, this is the exam blueprint, implementing Cisco IP routing, exam code 300-101. Again, this will change, I believe it to 304-01 or something like that. I don't remember. I was discussing it with a coworker, what the new exams were going to be and what it's covering. We just wrapped up the section 5.4a, but only did standard ACLs. Today we're going to cover extended ACLs. After that, we're going to move on to time-based and IPv6 traffic filter. So we talked about what ACLs are in the last video. I said that there are three types, right? Standard, extended, and time-based. I also gave y'all the analogy of the bouncer at a nightclub, right? ACLs are like bouncers at a nightclub, right? Because the bouncer is basically the router, right? He is basically letting people in and out of the club, right? And these people that are in line are the packets. He has this RSVP list, which is also known as the ACL or access control list, and he looks to see who is allowed in or not, right? They also, he also asks, now with extended ACLs, he's asking where they coming from and where they're going. And the reason why is because ACLs, we check the source address and also the destination IP address. Let's take a look at some more information here. Extended ACLs allow you to permit or deny from specific IP addresses to a specific destination IP address and port. So not only are we asking where they coming from, but we also asking where they going to, right? As opposed to standard, which only asks for the source, where they came from, Extended ACLs also you can also filter by IP protocol. So in other words, you can filter out just HTTPS traffic, or you can only accept SSH traffic. Again, extended ACLs are very granular. They're so flexible. You can create all kinds of rules and make it really complex, right? You can also do it by port number, such as Telnet is 23, SSH is 22, HTTPS is 443, and so on and so forth. So you can filter out port numbers, right? And the range number is also different. This is something else you might want to memorize. The range number for extended ACLs are between 100 and 199, and also 200 and 2699. That is basically the general difference between standard and extended. Here's the basic syntax for ACLs, right? It's just like standard, right? But except this time we do access list. We do an access list number or name, right? But in this case, it's a number. I believe with name, you want to put IP access list and then the name. But with extendeds, we do access list number. You can either deny or permit. Do the protocol here. So in other words, like in this case, TCP. The source address, where they came from. Wildcard. Now you can leave the wildcard out if you put host in front of here. So if you want to just check the source address of just, or check the source address of just this one source, you could do host. Like if it's coming from one PC, you do host, and then the host's IP address. You ain't have to worry about the wildcard. I hate doing wildcard masks because I got to try to remember all those wildcard masks. You got to do a lot of subnetting and stuff. So it gets a little confusing with that. Then you have the destination address where they're going to, and the destination wildcard. Again, you can leave that out if you do host, put the keyword host, and then the IP address of the destination. And then if you want, you could log these entries by adding the log keyword, but you ain't got to worry about all that because it make your screen look real messy. And then after that, the same thing, you apply a standard access list. You go to the interface. So in this case, interface FA00, and then you do IP access group, and then the name or number of the access list, and then the direction you want to filter, in or out, right here. So you put the name or number here, and the direction of where you're going to be filtering, in or out. And again, the general rule, Cisco recommends you want to place the access control list as closest to the source as possible. That way you kind of It's kind of like if we go back to this right here, instead of putting the bouncer all the way back here, right? We have him sitting all the way back here. We might have an extra bouncer, and you'll see when we add these different entries and different rules, those are called ACEs, or access control entries, that are underneath an access control list. So we can have like 6 or 7 different rules under this access control list. That's why it's called an access control list. It's a list of rules. Here's another example of extended ACL. I know this looks a little bit messy, but let's focus on this top part right here, right? This is, again, you start off with access list. You put the number, then you put whether you want to permit or deny for the rule. You do the protocol. So in other words, you could do HTTPS, you could do, you'll see, there's a whole bunch of them you can do. You can do SSH traffic, you can filter out all kind of protocols depending on the iOS version you have. And then you do the source mask, or actually wildcard mask in this case. I don't know why they put that there. Remember, I be finding these sources online. The destination, and then the destination's wildcard mask. And you could also put this operator here. And what that is, if I'll show you an example of that in this upcoming lab. For example, right here, we're saying this access list is number 100. We're going to deny TCP traffic from the source 199.240 wildcard mask right here. Here's the destination address, 202.34.5.0. This is the wildcard mask of the destination. And what we're saying here is we're putting equal to 23. So we're blocking, and do you know what port number that is? Pause it and think about it. I think I said it earlier in this video. Telnet 23. So you're saying block Telnet traffic from this source reaching this destination right here. And that's what we're doing here. You could also, instead of doing just equals 23, this EQ means equals. You can do greater than, or I think it's GE. I don't remember what the operators are, but you can do greater than, equal to, whatever. In this case, we're saying any port, or we're saying equal to 23. You could also put out the keyword. Oh, there go the answer right there. Equal to Telnet, right? So instead of putting the port number, you can do it by name, which I'll show you an example of that in this upcoming lab. Here's same thing we do with standard access lists. We do show access lists, and we can see our access lists. You'll see access lists like this. Extended comes below the standard ones, right? Here's our rules right here. This example right here says permit TCP from host, TCP traffic from the host 10.22.22.1. The destination is any equal to Telnet. We've got 25 matches. When you see these matches here, that's when you know your access control list is working. We're blocking FTP traffic from this host here, and we're blocking FTP data, which I believe is port 21, maybe? I don't remember. That's our pop quiz for today. What is the port number for FTP data? Not just FTP, but FTP data. Let's go ahead and not fire up GNS3. I had issues with the lab, the extended access lab. That's how come I didn't upload any videos yesterday. So I said, let me just go ahead and fire up Boston Netsin and do the hardest ACL lab that I can find on there. So we may triple up on this. I haven't even done it yet, so y'all gonna do it with me. I started to send Renee Molnar an email about this lab, but I was like, I ain't got time for all of that. I figured out what was kind of wrong with it, but I didn't want to experiment while I'm recording. So let's go ahead and fire up not GNS3, but Boston Netsim and play with extended access control lists. All right, so here's the lab we're going to do today. Supplemental lab, ACL practice lab 4, extended ACLs. Our objective is to create some extended access lists and verify the ACLs using show commands. The show command is show access -list. Here's our topology we're going to be working with today. We got router 1 and router 2. Don't worry about router 1. We're going to do configuring all the ACLs on router 1, right? Switch 1, 2, and 3 right here. We don't have to worry about those guys. We're going to bypass it. We're doing just layer 3 work. And we have a PC in each respective VLAN. PC 1's in VLAN 1, 2's in VLAN 2, 3's in VLAN 3, etc., etc., etc. And here's some basic commands right here. Here is how we define an extended ACL, right? This command right here, just access list, right? Just access list. And then you do the port number or the list number and or permit or deny, or permit or deny. You do the protocol source and then a wildcard mask, and then you could also choose do port number and stuff like that as well. That basically defines an extended ACL. These are some basic commands we already know, and this is how you apply it to the interface. You do IP access group. IP access group. That is how you create the ACL, and that is how you apply it. These are some basic commands right here. We already know how to telnet. This is some basic IP addressing guide right here. So that's all the interfaces and PCs and stuff like that. And here's what we can do. Task 1 is to basically test connectivity. We are going to, from each PC, step 1 says, from each PC, verify that you can ping the loopback 0 interface of router 1, which is quad 1, and router 2. So we have these guys ping router 1 and router 2. So let's go ahead and start with PC1, ping quad 1. Oops, that didn't work. Ping quad 1. That worked. Let's see if PC2 can ping router 2 or ping router 1. That worked. See, PC3 can ping that guy. That worked. Right? So all 3 of these guys can ping that. Now let's see if all 3 of these guys can ping router 2. Ping 2.2.2.2. That's PC3. And that worked. Let's see if PC2 can ping it. Ping 2.2.2.2. That worked. And PC1 can ping quad 2. That worked. Perfect. From each PC, verify you can ping every other PC in the topology. I'm not going to do that. I'm just going to have one of these guys test one of these guys. We'll have PC2 ping PC1. So PC1 is ping 10.10.1.101. That worked. And we know that connectivity works here. So from each PC, verify that you can telnet to router 1's loopback 0 interface. So let's see if PC1 can telnet to router 1. Telnet to 1.1.1.1. He's getting prompted for a password, which is Boston, and that worked. We need to get out of that. See if PC2 can telnet to router 1. Telnet to quad 1. He's being prompted, and that worked. Let's see if PC... Oh, that was PC2. Let's see if he can telnet. PC1 can telnet to quad 1. Pretty sure it works because this is a simulator. Again, all of this stuff is laid out for you. That's the reason why emulators and simulators are better, because all the stuff is laid out for you. All you got to do is just test, connect. Practice what you want to practice. But, if you want to learn how to build things from scratch, hardware is the way. So we know that telnetting works, right? Let's see if we can telnet. We'll just pick one of these guys that can telnet to router 2. So let's pick PC2. See if he can telnet to quad 2. Yes, he can. He's being prompted. Step 3, from each PC, verify that you can tell. We did that already. Oh, we'll see if we can. Yeah, we did that already. We know that we can. We'll pick one more. PC3. See if he can telnet to quad 2. And he's being prompted. BOSON. That works. Right? I don't know the enable password, so we're going to get out of that. All right, we know that connectivity telnet works. Step 5, create an extended ACL 101 and configure it to deny telnet traffic from VLAN 3. All right, so this is what we came to do. We're going to go to router 1. We want to create an extended ACL and configure it to deny telnet traffic. So we're going to go to global config mode to create an extended ACL. We're going to say ACL or access list 101. We want to permit or deny. Well, we said we want to deny telnet traffic. All right, so deny telnet. Well, wait a minute. Telnet's not here, right? Well, we know that telnet is a layer 4 protocol. Layer 4 is TCP traffic, right? So we're going to just remember that for now, the telnet part. We're going to say TCP here. What's the source host? Well, we said source host is going to be from VLAN 3, 10.10.3.0, using the port number, right? So 10.10.3.0. Now they want us to do the wildcard bits, which is the subnet mask is /24. So the wildcard mask is 000.255. Destination, they didn't specify a destination. So we're just going to say any here. And it says here to match, we could either do EQ or log. Now, real iOS, you're going to have way more options than this. You could do port numbers equal to this, port numbers greater than this number, port numbers less than this number. I don't know why you would want to do that, but EQ is probably the best way, and it's the only way we can do it on here. And we said that we're going to block telnet traffic using the port number. So the port number we know is 23, right? So we could do by word, but we're just going to do port number right here. So port number 23. We could log matches against this entry. We're not going to do that. So we're just going to leave it like that as is, right? Step 6, apply extended ACL to an interface and in the correct direction to prevent hosts on VLAN 3 from connecting to the Telnet server on router 1. Right? So we're going to apply the access control list here, right? So how do we block hosts from VLAN 3 to be telnetting here? Well, we created the access list, but we need to apply it, right? Where do we apply it? Do we apply it here or here? Well, obviously he's going to be coming from here. VLAN 3 is going to be coming from here to telnet and do it that way. So that means we need to place the bouncer, right? The nightclub bouncer right here, right? And then when he tries to telnet into it, that's where it should be blocked. So we know that's going to be inbound traffic from here. How do we know which interface on the router? We can get out of this and do a show IP interface brief. Well, that just tells us the IP addressing, right? Show CDP neighbors, I guess. Well, we know it's router 2 is the next door neighbor, right? So that guy right there, and he's on fast Ethernet 0.0, right? So that's what we need to block traffic from. We'll go to global config mode, interface FA 0.0, and to apply the access list, we said it is IP access group, right? My bad, not that. We said it's access. Yeah, that's what it was. IP access group. Then we put the access list number, which in this case was 101, outbound or inbound, right? We said it's going to be inbound traffic, right? After that, that's all we need to do. That should block them. So step 7 says here, from each PC, attempt to telnet to router 1's loopback 0 interface. Only the connection with PC 1 should succeed. So he should work. Those two should be blocked. Let's see if our access control lists work. Let's see if we can telnet to quad 1. He's being prompted for a password. That's how we know it works. So we get out of that. Let's see if PC2 can telnet to it. Quad 1. He's being blocked. It's a good sign. Let's see if PC3 can telnet to quad 1. And he's also being blocked. Good. So our ACL worked. Step 8. Modify extended ACL 101 and configure it to explicitly deny telnet traffic from VLAN 2 using the protocol name. Before we do that, let's go ahead and see what we've done so far and see if we have any matches. Right? Looks like we are blocking OSPF traffic as well. That's not a good sign. Show access list, and as you can see, we got a match here. I believe we should have had 2 matches. But either way, we're blocking TCP telnet traffic. So I don't know why it's blocking OSPF traffic as well. So we're going to go to global config mode and modify access control list 101. And he says he wants to explicitly deny traffic, so we know what deny. Next thing says deny telnet traffic. We don't see telnet here, but we know telnet is layer 4 traffic, so TCP. From VLAN 2, which is 10.10.2.0, right? So 10.10.2.0, right? That's the source address, right? That's the source address. What's the next thing we want? Wildcard bits. We said it's /24. The wildcard bits for that is 000.255. Destination, they didn't specify a specific destination, so we're going to say any here. Only packets on a given port number, right? We're going to say port number, but they wanted protocol name, so we're going to say EQ, and then they wanted the port number 23, but they wanted it by name, so we're going to type in the word telnet. You can do either, we can do either the port number or the protocol name. In this case, we're doing the name, which is telnet. Step 9, from each PC, attempt to telnet to router 1's quad 1. Only PC 1 should succeed. So basically what we just did, right? So we're going to see if we can telnet into quad 1. And we're being prompted for a password, so we know that works. Get out of that. Let's see if these two can telnet again into router 1, right? So PC2, telnet into quad 1. He's being blocked, so that worked. PC3, telnet. He's being blocked, so that worked. Let's go into router 1 and see what we've got so far. Enable and see our access control list. Show access list. And notice we've got a couple blocks right here. 2 matches, 1 match. So we blocked TCP from there from the beginning. We added another one. Notice that it gave us an automatic sequential number right here. So we're blocking specifically from that guy. That's why we got a match there. All right, so from each PC, attempt to ping router 1's loopback 0 interface. Only the ping from PC 1 should succeed. So let's go and see if we can ping from these guys. We're going to have all these guys ping router 1's loopback interface. So PC 1, see if he can ping quad 1. That worked. PC 2, can he ping? Ping quad 1. That's being blocked. That's good. PC 3, ping. That's also being blocked. Good. So our ACL is working so far. Modify extended ACL 101 and configure it to permit any traffic that does not match existing rules. How do we do that? Let's go to router 1. To add to that list, we're going to global config mode. We're going to say access control list. We're going to go back to the access control list 101. Right? We're going to permit. Notice this is the key words here, right? Says here, permit any IP traffic. We can just stop right there and see, we see permit any IP, right? So we're going to permit, right? What did he say? What kind of traffic? IP, right? That's pretty simple enough, right? Obviously, the exam ain't going to be that easy, but you just know how to kind of break down an access control list to see what they want us to do here. What's the next thing they want us to do? He says that does not meet any existing rules, right? And it says any traffic, right? So we know that any, they didn't say what specific destination, so we're going to say any here. And that's pretty much it. We don't really want to log entries right now. We don't want our stuff looking messy. Permit any. Permit IP any. So now step 12 says here, from each PC, attempt to telnet to router 1's loopback 0 interface. And let's see if that works. We're going to do exactly what we just tried to do. We're going to try to telnet to quad 1, and only PC 1 should work, right? Can he telnet? He's being prompted for a password. That works. All right, so these two should be blocked from being telnetted into router 1. So telnet into quad 1, he's being blocked immediately. Telnet into quad 1, sorry, you can't come in. So that worked. Perfect. From each PC, attempt to ping. All pings should succeed. Why? Didn't we just create something that's going to block traffic? No, but we created a permit IP any. So we're blocking telnet, and if anything doesn't match, we're going to permit. So let me show y'all again. Right? We're going to show, enable show access lists. And notice we're blocking here. We're just deny. If you don't match any of these rules, then you can come in. Right? But then after that, it's a deny, implicit deny, which is invisible, right? But either way, we're permitting any. So if you do that, that's going to permit anybody else. So now all pings should succeed because of that rule, right? Theoretically, hopefully. Ping quad 1. That worked. Can PC 2 ping quad 1? That worked. Perfect. Can PC 3 ping quad 1? Perfect. That worked. Step 14. We're almost done, y'all. From PC 1, go to PC 1, attempt to telnet to quad 2. So we are going to telnet to quad 2. So now notice he is going to try to telnet to this guy, right? Notice he's being prompted. B-O-S-O-N. He can log in. Why is that? Because we put an ACL right here. We didn't put no ACL. There's no bouncer. There's no extra bouncer. Just some of these nightclubs, they got a bouncer right here. And then at the front of the line, they got another bouncer, right? Or it might be, somebody else inside the club, right? That's basically, so we got a bouncer right here, but we don't have no bouncers right here. That's how come PC2 can telnet in the router 2, right? So the attempt should succeed. Create an extended ACL 102 and configure it to deny telnet traffic from Vlan 1 using the protocol name. We are going to create an extended ACL 102. So we're going to go back to this guy and we're going to say access list. My bad. We're going to go global config mode, access list 102. And he wants us to deny telnet traffic. We're almost done. We need to go to step 21 or we're almost finished, right? Deny telnet traffic from, so we're going to deny from who? He said telnet traffic. We don't see telnet here, but we know it's layer 4 TCP, right? From who? From VLAN 1, which is 10.10.1.0. 10.10.1.0. /24 is the subnet. We know that the wildcard bits is the reverse of that, right? So it's 255, 255, 255, 255 minus the subnet mask. So it's quad 000.255. And then the next thing is using the protocol name, right? So they didn't say specifically what address to deny. So we're going to say any. We're denying it to telnet traffic from VLAN 1 using the protocol name. So any, and then equals to. Remember, again, you could in real iOS, you're going to see equals to, greater than, less than. I'll give you an example. I'll probably load up GNS3 and I'll show y'all some examples. Equals 10. I'm sorry. They said by protocol name. So the protocol name we want to block is what? Telnet. So we can just type in Telnet here. And that's pretty much it. That's all we need to do right there. So that's access list number 102. Apply access list 102 to an interface and in the correct direction. Well, we know that we're going to block Telnet traffic from VLAN 1. We place the first one here on this interface. We need to place the other one here because that's how PC1 is going to telnet to router 1. He uses this interface. What interface is that? We're going to go to router 1. Well, we're already in router 1. We can do a show IP interface brief, right? We have the 192, the 10 network, and we did show CDP neighbors is how we did it. Show CDP neighbors. And we have router 2 and switch 1, right? So switch 1 is the next door neighbor. That's in fast Ethernet 1.0. So we're going to global config mode, interface fast Ethernet 1/0. Again, we could have used these pop-ups right here, but in the real world, unless you have like some kind of monitoring tool like SolarWinds or something like that, then it's not going to be that easy. That's why you got to learn these commands to kind of, figure out how your network is laid out. And we're going to apply the access list using IP access group 102. Inbound packets, right? Because the telnet traffic is going to be coming inbound on this interface, right? Inbound, that should apply it. From PC1, attempt to telnet to router 2's loopback interface. It should fail. So he is going to try to telnet to that guy. And why is it going to fail? Because we have an access control list there. So we already went over that. I'm going to get out of this. And from PC1, attempt to, let's get out of this as well, because we're in router 2 right now. See, remember we were able to telnet to it last time. See if we can telnet to quad 2. And it's being blocked. Why? Because we put an access control. We put a bouncer here. So now we got a bouncer here named access control list 102 who uses access control list 102. And we have a bouncer right here that looks at the RSVP list and it's access control list 101 that we did earlier, right? From PC1, attempt to ping to router 2's. We just did that, didn't we? Oh, attempt to ping it now. Now he wants us to ping it. So we were able to telnet. We couldn't telnet. Now let's see if we can ping it. Ping quad 2. That failed also. The attempt should fail. The ping should fail. Okay, so from PC1, attempt to ping router 1's loopback. So now he is going to try to ping router 1. Right? So we're going to ping quad 1. That failed as they said. Modify extended ACL 102 to permit any traffic that does not meet previous rules. So we're going to go to router 1 and go back to that access control list. So go to global config mode, access control list 102, and we want to permit any IP traffic. So we're going to say permit IP any, right? Permit. I'll break it down for y'all. Permit, right? He says any IP traffic, so we know IP. So any traffic, so any source, any destination. So that's why we put any and then any, right? That does not meet previous rules. From PC1, last step. From PC1, attempt to ping router 1's loopback interface and loopback 0 on router 2. Both pings should succeed. Remember, they failed last time. Now let's see if we can ping them. Ping quad 1. That worked. Now let's see if ping quad 2. And that worked. Perfect. So we can check to see if everything worked. And we've completed the lab successfully. Let me launch up GNS3 to show y'all the options you also have. right? EQ, and here's what I was talking about. You can match packets on a given port number. You got greater than, so you can do a greater than port number. You can do a less than port number, so on and so forth. You can match on, there's so many options depending on the iOS version you have. And here's what we can equal to, and these are all the different protocols that we could do here. You see that? Those are the different protocols. Those are the predefined ones right here. And if you don't know it, the name of it, you could just do a specific port number like that. That is all I got for y'all today. That is my YouTube page. That is my Twitter handle. Go ahead and add me on Twitter if you want to connect. If you want to shout out or anything like that, go ahead and put a comment below if you think there was something I could have done differently or how else I could have modified these access control lists. Go ahead and share this video if you like my teaching style. Go ahead and hit that like button so I can get some more subscribers, and so that way it can help the SEO of my videos and stuff like that. I really appreciate, everybody following me and stuff like that. Because really, I just did this to kind of document my journey, and I have built a little following, and that's pretty nice. Anyways, go ahead and comment, like, subscribe to the network, bro.